Hey all, finished the 2.3 notes, and this is really going to be about the position, velocity, acceleration, and how they relate to what we just did on the beginning of 2.3. So here we're going to relate the position, velocity, and acceleration, okay, with the derivatives on their graphs. And we're also going to talk about speed and where speed is increasing and decreasing. And if you recall, we've already seen that if s of t is the position function, and again, we could label it in something like feet, s prime of t is the instantaneous velocity function, and that would be something like feet per minute. And if we took the absolute value of that, then that would be speed. And the second derivative of position, the first derivative of velocity, is the acceleration, and that would be something like feet per minute squared, so feet per minute per minute. So we've been seeing that already. Okay, so let's look at these graphs. I'm going to zoom in just a little bit. So let's say that this is our velocity function. So here we can kind of talk about, here velocity is constant. Here you can see the velocity function is decreasing. So like if your velocity is like 3 miles per hour versus 0 miles per hour, right? And then all of a sudden here my velocity is negative, my velocity is constant, and my velocity is increasing. Okay? So that's still a positive velocity. So here I can see, here are some points where velocity went from positive to negative. So if velocity goes from positive to negative, then the position function will have to go from increasing to decreasing at that point. So that point's going to be a relative max going on, which we'll talk about in chapter 3. Alright, so here let's say that this is my speed, and you can see that all I did was take this down here below, because it takes the absolute value, and it flipped it up right here. So it flips it over the x-axis, or in this case the t-axis. So here speed's going to be increasing from 3 to 4 and from 9 to 11. Speed's going to be decreasing from 2 to 3 and from, what is that guy, 6 to 9. And speed is constant from 0 to 2 and from 4, is that 4? What is that, 4 or 5? Shoot, I think I called that 3 to 4, that was 3 to 5. Should have drew my little line. Okay, there. So that was 3 to 5 up there. So that's going to be from 5 to 6. Now this graph is the acceleration function. And here I can see acceleration is 0. Well, remember that acceleration is the slope of the position, because it's the derivative, of the velocity. Because acceleration is the derivative of the velocity, let's look back here. From 1 to 2, I can see that my velocity, or speed, was constant. We'll come back up here. So here my velocity is constant, so the derivative is 0. And remember, this point right here is not differentiable because it's a corner. So when I look at the derivative, I can see at 2, that derivative isn't defined. It does not exist. Okay, look back up here. This velocity, if I look at my slope, let's say I go down 3 over 1, so that slope is a negative 3. And what do you notice about this acceleration? It's a constant at negative 3. So think about it, this line would have been, whoops, too far, sorry. This line right here would have been something like y equals negative 3t, or v of t, I should say. V of t equals negative 3t plus some y-intercept up there. So if I took the derivative of that, I get out negative 3, which is what we see down here. How cool. Again, this is where it's constant. And then here I have a positive slope the whole time of 2. So constant and positive slope of 2 on v of t. So that's how it relates to a of t. Pretty cool. Okay, so if I look at speed, speed is going to be increasing when v of t and a of t have the same sign. So they're either positive, positive, or negative, negative. And speed is decreasing when v of t and a of t have opposite signs. So it's like positive, negative, or negative, positive. And speed is constant when v of t is 0. So kind of looking back, if I look at the speed, here v of t is 0, so speed is constant. Here speed is decreasing, and I can see, let me get a different color really quick. This is pencil. So here speed is decreasing right there at that 3 part, and at this 3 down here from 2 to 3, I can see that a of t is negative and v of t is positive. So that would tell me that speed is decreasing. So then speed is increasing from 3 to 4, and from 3 to 4, velocity was negative and acceleration was negative, same sign. And I could continue that with the rest of the graph. Okay, so let's look at this one. And you get to use your graphing calculator. So it says a particle moves along a straight line between 0 and 5, and the velocity of the particle is given by this function. Okay, so there's my velocity. The position of the particle is s of t, and I know that s of 0 is 10. So it says find all values of t in the interval from 2 to 4 for which the speed is 2. Okay, so speed, if you remember, is the absolute value of velocity. So we're going to say that it's the absolute value of this entire function. Don't break it apart by pieces. Don't like say positive 2 or anything like that. Put absolute value bars around the entire function. And we want to know, where does that guy equal to? That's the question. So what I'm going to do is I'm actually going to set it equal to 0. I like this feature in my graphing calculator better. Let me get my graphing calculator and show you what I'm going to do. You guys getting your graphing calculator too. Okay. So I'm going to go to my y equals. And I don't care if you use an 84 or an 89 here. And I'm going to type this function in. So second catalog to get my absolute value. I'm going to put in the entire function. And then, let's see, I have -2. So I put all that into my y equals from what I had here. And now I'm looking for where that guy is 0, but I'm only looking on the interval it said from 2 to 4. I'll zoom out just a little bit. Okay. So I'm only looking on the interval from 2 to 4. So I'm going to go ahead and change my window and just go a little bit around that. And I don't have to go really far up or down because I'm just looking where it crosses that x-axis. So I'm going to go -2 to 2. So there's 1, 0. There's another 0, another 0. So I see 3 zeros here. 1, 2, 3. Possibly one right there. So let's go find the 0. There's my little blinking guy. I don't think, I'm just kind of looking. That's still negative. Okay, so it looks like at 0, 0. Oh, but I'm only going, I don't know why I went like that. We're only going from 2 to 4. Silly. 1, so there's my 2, 3, and there's my 4. Okay. Oops. So then, I'm only looking for these two. So here I found 1, or in our case t, is approximately 3.1276, and then we'll find the other one. .4734. And so those are the t values that have a speed of 2. Okay, part B says, is the speed increasing or decreasing at time 4? So now I'm going to go look, I'm going to get rid of my absolute value bars here. I want to just look at my velocity function. So I'm also going to get rid of that -2 because that was from when we wanted to find where the speed is too. So I just have my velocity function here. And I'm looking at time 4, so I'm going to change my window a little bit so that I can go a little bit higher just in case, or a little bit lower just in case. And let's see what's going on around 4. 1, 2, 3, 4. Okay, so at 4, it looks like my velocity is negative. So I had this function going on. So let's actually see what it is at 4. So v of 4 here is a negative 11.475-ish. I know I truncated. If you wanted to round, you could, but whatever. Okay. So v of 4 is this. But I also see that the slope, so a of 4 is the slope of the tangent line at v of 4. And I can see that that slope is going to be negative. That slope is decreasing. So here I see that both v of 4 and a of 4 are negative, which tells me, since they have the same sign, that speed is increasing. Now, you also could have actually went and taken the derivative of this guy. So let's take the derivative if you didn't want to look at it graphically to find a of t. So let's see, -2 is a constant